Limite, ce que ça faut que je coupe. Enfin, 45, moi je me casse, regarde, j'appelle le mec. Je voulais le chercher, oui, après, ici, il fait comment? Non, normalement, je t'en pas. Ouais, bah, va le chercher toi et tu vas voir. Le mec, du coup, ça s'appelle comment le vieux Stéphane, tu fais ça. Ouais. Ah, ouais, c'est l'hiver, mec. C'est le second qui en avait pas. Il dit juste de fermer sa gueule ce matin. Ok. Il s'appelle Stéphane, Stéphane Cussac. Il en a préparé. Lucien est allé le voir, et je vais le voir. Voilà. Ouais, il me semble. Mais je suis sûr, je suis pas certain. Ok, mais sinon, allez trouver le gars et fermer sa gueule. Ok. Ok. C'est ça. C'est mon. Non, pareil ou pas? Parce que pas précis. Je serais me chercher une bouteille d'eau. Bon, ça, il faut. Donc, si je demande au gars, il faut peut-être une bouteille pour ça. Et puis, je change la caméra. Je change la caméra. Ça lui prend 30 secondes. On peut avoir accès à la régie. Je cherche une bouteille d'eau avec le gars. Euh, ton cours, c'était d'Artem? Ouais. Je vais l'envoyer. Comme ça, les gens pourront suivre. C'est ça, ouais. Ah, je pense en. Les... Ouais, non, c'est bon. Moi, je prépare d'arriver. Je vais aller voir avec Maxime pour. Ça fait un peu chier pour les couilles, parce que. Tu l'envoies en contestation. Regarde, si le cours à haute voix comme ça passe. Ça va être un peu chiant. Il fait une captation de son. Non, mais là, il est bien en cours, peut-être chez toi. J'en mange. Bon, écoute, bonne chance. Merci. Donc, j'attends juste là, en fait, que le mec a des occupations. Faut juste laisser live tourner en arrière. Je ne peux pas toucher à ça. Ouais. Et quand t'as fini, t'appuies sur l'interruption. Ah, la chose. Et ça, j'ai juste à l'allumer que je pour ah oui, c'est bon, ça, en fait, je saurais dire que c'est ça, le mec, vraiment, va te lancer, mais sinon, c'est tout fini. Ok, regarde, vraiment, c'est. Ok. Donc là, si tu fais ça, tu peux faire un grand peu plus. Il sera peut-être déjà arrivé là, c'est comme en 45 quand il est arrivé dans son bureau. Je vais directement. Je vais voir ça et je vais trouver l'histoire. Sinon, on va essayer de se caler comme ça le PC de là-bas. Il marche pas, c'est bon. Ah non, mais il faut aussi. On va faire il marche pas. Peut-être, genre, il est salut ou pas? Il est out. J'ai pas testé. Je sais pas comment on l'avait. Non, mais bon, j'ai une cravate, c'est chiant de toute façon. Allô, allô. Non, je vais pas le. Ça, ça marche. Nickel. Non, ça m'étonne. Ça m'étonne. Attends, si tu fais pas de ceci, en fait, les pieds, c'est mal. C'est ça, ça va. Ça va changer. Non, ça va. Non, du coup, c'est pas terrible. Ok. Bon, merci. Ah, attends. Adrien? Adrien? Il est là, pique. Il est resté là. Je pense. Il est parti chercher le. Ils ont au milieu du. Ok. Il allait chercher le micro-cravate. Le live, c'est bon. Et ils vont changer la caméra parce que le live qu'on a de.
Tu veux que je m'assoie où dans la salle?
Au milieu. Au milieu. Et les 4 chaises devant, c'est pour ceux qui arrivent en retard. C'est leur mission. Ils vont changer la caméra parce que là, on a. Ça sert à rien parce qu'avec moi, pour moi, c'est bon. Donc, ce qu'il faut sur la caméra. On s'en fout. Ouais. C'est très drôle. Ouais, des questions débiles. Pesant assez pour que j'ai besoin de te virer. Vraiment, bon, pas au tout début, au café, mais au 10 minutes. Vas-y, quoi. En mode, moi, je comprends pas ça et tout. Moi, j'ai déjà l'entendre ici, puis au bout de 3 fois, je dis alors juste des questions, je dis pas de questions, tu te casses. Ok. Non. Les films d'élèves, je vous donne. C'est quoi? Les films ah ouais. Bonjour. Je vais essayer de brancher le portable sur le portable. On a un YouTube là. Une histoire. On a enlevé sur moi directement. On a branché une caméra. Ah, vous enregistrez. On a une grosse caméra en dessous du bureau, elle est cachée. Ça, c'est pour essayer d'entendre en tout cas ça. C'est une grosse caméra de. Adrien. Enfin, oui, ça fait. Et là, vous enregistrez avec cette caméra, c'est ça? Oui. Et le son, on a un gros micro, et puis après, il y a tout qui est enregistré par le codage. Et ouais, le point de vue sur les élèves, après, comme ça, on a leur réaction. Est-ce que c'est possible de décaler un peu sur la caméra pour qu'on voit mieux les choses? Je n'aurais pas prévu de décaler un tout petit peu pour arriver à cette caméra. Ouais, toujours ça, il Yes,
So, as you can say, American, English. My name is I'm currently doing my PhD here. I study at Columbia University, so for the master's in computer science. Actually, French, even though I could. English is a very important language in computer science. Most of you will use this later on in the industry, and you won't use English. So I just think it's better for you to kind of grasp the whole concept. Also, you should know that tomorrow you have a test. Every subject that's like a general test. So there will be some of this class and try to listen to and again, so I'm not trying to be mean or everything. There's just this is a really important subject. So everybody just do the exercise. I'll kind of pick up class, and if someone did not do it, that would be good. You might. So okay. So just take a look at these very important keywords this time to get graphs. Then I'll be using them in this course, this semester. Doing stuff like else. Some of you maybe already know them, so. All right. So let's start with the basics of the language. So, like A, Z, or whatever you want, wants a character. You write car, you could say car, or driver, or character, you say cars. Kind of pretty hard, but you can say however you want. And the mots entier, either written in like in Python. I don't know, did you already do Python? Yeah? Yeah, great. Then you can have a short Python and long Python. That just means the precision, long and short and number of bytes of what you're writing. You have close, so I think you already know that too. And finally, something really important: no Boolean types in C language. That's really important. No true, false. Keep that in mind. So you guys already know what a character string is, maybe. So character string is really easy. Got there. It's kind of a sentence. Just separated with those two signs. And slash m sequence, that means that you go well, from the code at least, go to your next line. Just and finally, you have to remember that a string contains the null character code. Well, you actually have the null character at the end that's encoded in the machine. When you do a dynamic memory allocation. Finally, what's a constant? That's something that you probably don't know about because nobody uses it. But a constant is if you declare a variable, but you really don't want it to move throughout your code. Physics, for example, when you want some stuff never to change, like the speed of light or stuff. Oh, great. That's how I write it, yeah. Hashtag a constant, and then you have what it contains. And so from now on, a constant will be replaced by when we'll talk about compiling and stuff like that, you'll understand better it's basically just faster for the machine than declaring a variable. And finally, don't forget with cap, no small letters. I will not tolerate that. Very important. Okay. I guess you don't know what a variable. So if you want, I mean, your code will be really long this year. One of those with Python, that would be like really big code. You declare all variables at the beginning of the program. It's just as clear. And something that's completely new for you guys is that you have to specify the type of the variable. I don't just say I in Python, what the fuck is I? It's an integer. For anything. So if you don't do that, just your code will have errors and it's really bad. So that's the reason to get. Now we'll talk about basic allocation. You all know about obviously equals sign. Then you have your some multiplication, whatever you want. These are classic data words to say that whatever we did. You can also use parentheses. What happens is that k is out is the value, and then the operation I equals the value of k plus 1. That is priority thing, just like a map. Now we'll talk about the modulo operator. So modulo is, I think, you same way in Python, dividend divider, division. So that's pretty simple. One thing, so it's you're playing on anything. Even simple stuff like if you have something, it will always be negative. It will be generally negative because your machine is, machine state is numerical. That's some good. So just don't expect it always to be I'll talk about the comparison operators. So I mean these are, you don't know these, I don't know what. You know that, right? And those Boolean types, but some hard-coded library allows you at least give 1 or 0 in terms of true or false, so that you get like kind of a Boolean the same machine, but that's what the memory when we test. It's not going to be if it's true, it's going to be if. And for Boolean operators, I think it's some of the K and C section, something like that in France, inside section. Some of you may did that or maybe empty. Normally you did like logical circuits and stuff like that. For the people who come from the physics and chemistry class, well, I guess you'll have to look on Google, but for the rest of you guys, so now we're going to introduce some interesting stuff. Instruction structure. You already know that, right? Also, come on again. So if logical structure, then you have instruction, else, that means the instruction false, and you have another instruction. Just watch out for brackets. You'll get it by coding, but they kind of shares an interpretation, which means that this already happened. While here it's kind of so just watch. Right. 4 is a bit different. Now we've got a meter. I think it's a condition, obviously. We got what happens to the meter. So
Sir, what's the law?
what?
Sorry.
Oh, it's a loop, sorry. Wow, yeah. About the past then. Yeah. So so each time the meter increments, the instruction happens once again. The instruction happens once again until and you reach the final condition. So here we've got an example. Start at value I equals 1, I equals to 6, and then the conditions kind of increment 1 by 1 each time. And what happens each time? Well, you print the value out. That's I say you print I when it's here. So paradox. Okay. Now the while instruction. It's not a condition. It's a loop too, but the loop is hey. So while condition. That means that it's a loop because sometimes it doesn't end because it won't reach the condition loop and your computer will freeze and just start. I mean, it's so bad in the code. So well loops are you gotta watch out for them, use them. Once you have a reflex, it'll go away. Right. Breaking continuous instructions. So I just talked about the while loop and how the safeguard here. Tell me the value of the meter. That means if you know one value of the meter, for example, something 5 by 0, I don't know, will make the infinite well avoided. It's not before you can do a test, logical test using the configuration. So I talked about if, then this is just for a lot of cases, right? So let me take if conditions like this, So just got several cases. That's a nomenclature. I'll give you a few seconds to write it down. Good. So functions. These are like the basic. These are the basic stuff in every. So it's got something kind of changes depending like we're there kind of. So first you'll declare out the functions in a separate file, where you just give the type of output of the function and the parameters. That means that the machine knows that there's a function and you can kind of work out with it. So that's a separate file. Any file will define that we're still have the output. First, then got the instruction sequence, return out. Kind of the motor of the function. I mean, it's really important because the function, if you want to clean code, just won't be clean. When you do advanced code, you'll have like 20 parallel files and it'll just be it's so much easier to define separately. So no Python. So now the return instruction. Each function is one return instruction. As you know, the return instruction gives an output or just return. It stops the function. It has to be the last instruction function. If, while, whatever is or condition, but at least at the end of kind of a block. Yeah, the exit function will be another time. Void is really important. Void is nothing. Void really just means nothing. So that means that you can have a function that doesn't take any parameters, or just say function, but you have to say it. Also, there could be a function that doesn't return anything. We'll talk about that later because they use what's called pointer. It's really rare. You won't really use them. Generally, you just won't. It doesn't return. Okay, so talking about pointers. So I guess you all know about cables, stuff like that. Kind of declare the type of what's inside your table. You can't declare the size of your table, give it a name. Table is a shell for your variables. They have so this is the defined. This is nice to this is the constant thing I talked about. What you have to understand is that once the site, we'll see later that you can define it after defining the table. But once it's given, it's static. And that's in Python table elements are next to the minus one. If you have elements, right? You can create a 12-dimensional table. If you want to have fun, it's not blocked by C or anything. And there's several ways you can initialize it. So that's kind of like the easy way with a small table, but it's kind of long. A few of the slots. You can have like a string works the same way. And finally, as I said, initialize it when you initialize the table. Right.
Excuse me. It was written that the table 0
I can understand.
Yeah.
We'll give estimate. Right.
There's a mistake.
Where?
It was written just before that 0 and 9, and then you write that you take it between 1 to 5.
Oh. All right. So that means there was a last question because I need for the session. So last good observation. Thank you very much. These slides. Good. Thanks. What's a pointer? You know what a pointer is? Hands up if you know what a pointer is. No, that means you can. So, if you ask a question, find out what is things to address variables. So, if you want to declare a pointer type variable for a base type, just remember, once again, probably with German and Austrian that's great because that's if it keeps like after a year, you'll great code slides. If you want to declare a pointer type variable, you start with the base type variable declaration. Close whatever you want. That's the base type. You add a small asterisk. So that means that this is a pointer toward an integer. That points towards an integer type. That means that the value is the address of an integer. It's very useful. Find one variable called I, and you want to keep its address, or use a pointer. You modify I by using the pointer. Create a generic pointer. These are like really dangerous because if you have it, use that. So finally, I was talking about addresses. So because the current type want to access initialize pointer. So that's how you do it. Imagine you have the well, this this and I is the address of I. So if you initialize it, if you give this pointer, that means that the pointer will contain the doing something to the pointer. Well, notice that I put the asterisk here, not here. I talk about it in the next step. So it's called the direction operator. It's a prefix. Basically, it carries out. So what is it exactly? Well, this is a pointer, right? That's when I write just p without the asterisk, the value PD, it gives me an address 0x x. If I put it with a star in front, well, sorry, the asterisk, it gives me what's contained. So if I initialize the pointer to I, let's say, and I had to put the value 2 to I, well, asterisk PD is only doesn't give me 2, which is really interesting because it actually modifies I, meaning the pointer, it'll actually do stuff to the I is contained and not just do stuff to 2. I'm familiar with this because in Python, this is the dynamic. That means that your function, whatever you use, kind of detects what you're trying to do. It's smart in a way, and so it knows if it has to use pointer or not. Because you're using a function with parameters, and the function modifies wanting to modify a variable, and know that in the end the variable. See that does not happen. If you put a variable in your function, it will just do something with the value, but it won't change the variable. With the pointer, if you put it in the function, pointer modifies the variable. So pointers are present in every language. It's just that you actually have to use them here. They're not. It's not done dynamically. So I gave you some examples. The pointer. Because the next is an address. So if you have an address plus a value, it just goes to another address. So you've got it, where you have to use it in the table. 2 pointers. You can address the first element of the table, and then each address of that element plus equals 1. So you're just directly going to terms of addresses. It's really easy. It's just think of it as like you have on one side the variable, the content, everything, and on the other side the accuracy. I talk about tables, I talk about tables, why not? So pointer tables, when you need multi-dimensional table. So that means that I talked about multi-dimensional tables before. It's not just like T one. You can actually have different directions in the way in which the table goes. And use pointers because first of all, if you want a multi-dimensional table where all the lines are in, so you can have like one long line. Well, the points to the first element of your table, once that's given to your, then you can put whatever you want after that point. You can have like those elements that doesn't care. Your pointer table only contains that first element, that pointer. So if you got 4 pointers, 1, 2, 3, 4, whatever you want, and that kind of points to a list of elements. Before you'll be using that. And that's why I actually meant the first elements. Which direction you're looking at each line, but you have to look at each line, or directions for elements, you're going to be a low whatever you want. Because of the pointer, depending on which line. Right. Maybe you know about structures. I'm talking about that, but you think I use those are really useful. I mean, I would we actually use our structure. Structure is useful because it's kind of like a definition of something. You, the person, you have a area, I don't care, but basically you have kind of a definition is what you give to structure. I can put inside, I can put another structure. I don't care. You can just define kind of the dictionary. global package. So, as I said, we're trying to create one, all right? What you have to remember is that person is the signature of the structure. I'll show in the next slide. You can access the content of your structure. So, for example, I created the person structure before, right? This is how I initialize structure Q1 and another structure Q2 once I define what the structure is. If you want to access the content of the structure, you use docs. We had person, we had like last name, first name. Well, person point last name, that means you're accessing the last name person point number number. And if you want to initialize the structure, right? And remember what I said about functions, how you kind of name it be the same here. I declare structure, but you still have a structure, right? And so if you want to put stuff inside, you can use the same the brackets, or you can do person equals to what you want to contain. So that's kind of useful. Basically, just initializing is similar to tables. Tables, structures, structure tables. Right. So there, a structure table. I mean, the same as a table. It's just in to flow or whatever you want. Right, and what your structure is. Don't forget, you can't just say structure and small person, but you have to construct person. You will see later on if you can use what we call aliases, but for the moment, just use that. Because that doesn't mean you're using the person structure. And the same as with tables, where first of all, you access so the I of the structure in the table. And you want to access one of the parameters, one of the so once again, watch out because maybe sometimes you'll have a structure in the table structure that happens. Use no parentheses, so you're here with what you're working on, right? Okay, linked lists, these are fun, they're really useful, that's what they know. So you already saw lists in Python, I guess, these were quite easy. A chain list, linked list. That's when you don't know how many elements a linked list is fun. This structure you can apply to anywhere. Each element of your linked list is like the person is going to be one. But there's one thing that never changes, that at the end of the structure, you have a pointer. That points the structure of the element. So you can say what's the context, right? Instead, you have one structure, right? That's the small element of your list. And so on and so forth. So it's really easy. That means that if you want to use a list, you just have to know the first pointer, just the first structure, because the next one, the next. So these are really easy to use. And to it, I can add many more aspects to lists. If you use something to list, automatically changes a variable list size. Really useful. So, so I got it. Good. Finally, if you have a list structure, so I say there's a next, and next, and next. At the end, you have a null pointer. It's not right. The fun has to end. You have to have a null pointer. Whereas null is kind of like going to points to nothing. It's still a pointer, but it points to nothing. Yes, physically, because you already said that it has to be. layer. If you want to point to anything, well, just look at the notes. Okay, so in Python, there's variables and functions and everything, giving memory access. Just in functions, see what happens. I don't care, right? So it doesn't work. You can do it, but really quickly your program will get overflooded with information, with memory that's for everyone. You have to remember this language is tens of it looks like mathematicians. Here's my fairly simple aspect in mind. You want it to kind of work. They count on the user. Right? So this is something that's going to be more highlighted because it's useful and interesting. Each element in C kind of has a memory size, right? In bytes, it's whatever you want. So if you want to know the size of a structure, or also works on like integers or floats, you use the size of it. The memory size of what you're using, right? And so you can give it to your variable if you want to keep it. And it's useful because so we're going to have other classes on that, right? Later. I'm going to introduce you to the concept. How do I put this? If you do something and use it, it's an automatic allocation or memory allocation, which means that it kind of floats in the computer and makes it slower and slower, and the program after 10 minutes will really slow. Dynamically allocate memory, which means that it kind of say, well, I'll create a structure, I'll give it that size, finite, compartment, it'll be kept until you delete. That's useful because that means variable for like one small part of the program is useful, is deleted, and it's once again it's so for that you might use those in Python. It wasn't the same nomenclature, but you still principle. It's just it gives you values that you want to use. So here you have to use the STD. This is really useful at like we use it all the time. Point H is not going to see the point H because all libraries are with the point H. You can't compile them directly. So is malloc. I give computing instruction dynamically allocate. But obviously, you've got to say what's the size of what you're giving it. So that's why we use. So let's say first, that's kind of weird here. You want each to be a person. What do you want to do first? You're going to dynamically allocate memory to it. That means that I dynamically allocate to the size of a person. Once you did that, you can initialize the structure, you can do whatever you want. Remember, watch out. Uncle Ben's great responsibility. If you use it all the time, it will pile up, pile up, pile up, and your program will just stop working, right? Thanks for getting this over. So, you have to screenings, I believe this thing. Kind of one days before we gotta remember. You gotta each mount for color content. So check that, right? When we compile, it's the easy. Okay. If your memories allocate memory and you haven't created so it ends up not working. Your program basically is slow. If you do that in the industry, like fire, you can crash after 10 minutes, and if your program crashes because of the memory, this is the exercise I want you guys to use, okay? I'll give you time to copy the exercise. Really, that's like easier. That's like that. Don't worry, dude. 10 minutes. And one thing you have, I mean, computer classes, computer science classes, if you want to study computer science, you'll never know everything in computer science. So one thing you gotta know, maybe some of you guys already know it's website, all the coders are on there, they get tools. If you have basically a question, and like the C language is one of the most used languages, and Stack Overflow, we'll have at least talking about, just click on the table with their code. That's the best way to learn, and you'll discover new tools, new ways to that's, I mean, a teacher or doing it alone will never equal getting help from there are much more experienced. You guys over? Oh, by the way, I don't know if you guys use PowerPoint, stop using it, start using like better. You can do anything you want. PowerPoint with like your science. Remember that. If you use PowerPoint, you'll get some bad grades. I swear. It's not, we're not actually doing no business schools with it. So here. This is like an easy, and you went to go inside and put this stuff up. Hey. So I'm sorry if this class was we have 2 hours to it, to sure have a so first of all, that pisses me off real bad, but also that means that you get like machines that don't kind of goes quick. So and no, not one guy. Yeah, human might kind of. Okay, so you get it, like your team. Finish? I mean, if you do that one, you get like a really good grade. I mean, hours to influence all teachers here and give you a good grade. It's like, right? Pretty doable. We all like to stuff. For some of you, you know how even if it doesn't work, if you try it, you'll probably get like 100 more points. If you try something that returns shit, but it kind of looks like a bonus for a lot of folks. Okay. No problem here. So now I'm going to talk about some interesting stuff. Clean code. So what I'm going to do now is I'll try to come back onto the slides I talked about earlier so you can understand it more. So a point C file is a C file, right? It's pretty logical, point C. Also a C language file, but it doesn't have to remain the same function. The point C file will be kind of your main the definition of the functions, that kind of stuff, where you what you're using. Files are kind of like index references. Page files will put the declaration of your functions. You'll declare your structures, stuff like that. We'll just declare everything. So don't ask me why, but basically 25 years ago thought that was, I guess the code is clear. That if you use a C, one C file, you got a label. You use another type of file that's later semester, which is basically this is going to the point H file that's in this repertoire. The main point C, you always have to have a main file. That's really what you do. You could also have like annex files like Python, where you have small functions like that, where the beauty happens. And so as clean as possible. I will not even consider looking at shitcode. I'm serious. It hurts my eyes. It's really bad. One code, 189 is like suicide bad guys. So and yeah, like function calls and stuff like that. Beforehand the point H stuff, which means that you can directly use what you declare in the point C. All right. Okay, so compilation. That's something you don't know about because in Python, what was Python, well, you kind of double click on the program and the window that where you have like this small window bottom right, you have like a big window on the left, and let it rip, let it start, it will work. Here's not the same thing. A C program, I mean, you could write it or something. It really is the same. It's just a series of characters, right? What you need is a compiler. The compiler is where all the magic happens. The compiler is code. The code can be like written on anything. You just and you save it as a point C or point H. That's it. The compiler isn't that easy because we're making you would say, oh, you've got a nice you should go correct. No. Compiler would be like shit, and you just be fucked up everything. You'll be like, okay, well, my code has 3,000 lines. Gotta go check it out, right? So that'll really teach you clean code. I mean, that really is life-changing experience. It's not life-changing. In the simple case where you have one file, as I said, use the command. If I offended anyone with the violence, I could go to I don't know if anything has me now. So GCC, the most known compiler we use. We'll actually install it. It'll be installed in the, I think, where we have our computers. But if you want to send your mail, I'll give you tutorial instructions to install what you want on the machine so that you can work. Yeah. GCC is the main file. It's the one we like to install. GCC file, and that produces a point out file. That file can do stuff with it. It's just kind of set or creates. So, and once that's produced, you run it. But you can't really look inside stuff. It's just you run it. That's executable, right? Executable is kind of like if you want to run the game. Also, you can't give it a name. Using this GCC program, and then you give the name to the execution. You want to probably do with Facebook, because you feel you have a little power. Just clear your program. See, it's really simple. That means that in your life, you have a Facebook execution. Finally, okay. Now, your code will not be perfect on first try. You'll have bugs all the time. It's like it's the devil. It's really bad because it gives like a bunch of red stuff you don't even remember, and you have to your science. So what do you use? Right? Use a debugger. Once again, that's something in instructions by mail. If you want to have it on the computer, that is. So, and here program. And instead of it'll learn debugger. It's kind of the same as a compiler, but it stops before the end of its calculations. So your code in a neat little window will be able. Some of you already debugged that thing. Even maybe some of you already did C, I guess, or something like that. Well, you already know what it is, but for the others, it's just right, a little 80s fashion window, and you have a little like dot, and you can start and you can push a little button. Dot will go one instruction. So instead of like trying to compile the whole of your program, all right, so this works, and you have you can actually show them variables and stuff, so you kind of know how it evolves. So you understand. Maybe that'll give you insight to correct another error. So it's kind of simple, right? But it's not. I mean, like by retarded cat. Actually, bad. It looks really bad. It's just it's useful, but it looks bad. You have to get used to it. You have to do or use it. But it's really important. I mean, here, somebody here like so I mean, that's like that's great. You look at Airbus, you'll great planes and stuff. You not give a shit about that. Well, computer science, whatever you do, will be useful. Even if you don't use C, you'll use at least one language. Even while we're doing C, which is kind of complicated. It's like the most basic level language. It's the closest to the computer. You saw you have control over stuff that's never heard of. In that language, you'll be able to understand. I am that serious. And if you start by another, that's why I understand what you're saying. Python is used by data analysts or stuff like that. You don't use Python. Anyway, okay, I've gone far. Right? So what can you use? So as I said, you got window, that's one use. Each time you run it, it creates trash. That's a file. Well, sorry, I'm going to take it. I'm sorry, forget that. When you there's an error, that's great. And then that done by with GB and kind of gives you better insight over what happens in the file instead of you having to look out by yourself. Tell you, okay, there's a problem there, there's a problem there. Not all of them, but some of them. All right, so you have about 3 minutes because we actually leave in like 3 minutes for nostalgia, which will be specific with me on that. If you have like, I'll just take like one or two questions. And if not,